Hello and welcome to the Math Studio. In this video, we're going to look at an application of trigonometric functions of compound angles in solving equations. So let's have a look at this particular example. Solve for x, inverse tan of x over 1 plus inverse tan of x over 1 minus x equals inverse tan of 6 over 7. So I've written out the solution already, so I'm going to step through that with you, and that way we can save a bit of time. Now, I think first thing to realize is that inverse tan of a ratio is in fact an angle. So this is in fact an angle, let's call it angle alpha, and inverse tan of x over 1 minus x is a different angle, let's call that angle beta. And that's in fact equal to inverse tan of 6 over 7, and that's in fact another angle yet again. So that's an opposite over adjacent. So what we're going to do, we're going to start off by letting alpha equal inverse tan of x over 1 on x. Again, understanding that the inverse tan, in fact inverse sine or cos for that matter, the inverse tan of a ratio is in fact an angle. So I'm going to represent all of that with alpha, and I'm going to represent inverse tan of x over 1 minus x as beta. That means then I can rewrite the equation in terms of alpha and beta. So alpha plus beta is equal to inverse tan of 6 on 7. Now to eliminate the inverse tan or the inverse this inverse trig function there, we can take the tan of both sides. So the tan of inverse tan of 6 on 7 is just 6 on 7, of course, but what you do to one side, you got to do to the other as well. So then you end up with tan of alpha plus beta is equal to 6 over 7. Now the next thing to bear in mind is that if alpha is equal to inverse tan x over 1 on x, then tan of alpha, so taking the tan of both sides there, tan of alpha is equal to x over 1 on x, and tan of beta is equal to x over 1 minus x. And that's going to come in very useful shortly. Now, expanding the compound, this trig ratio of a compound angle, so this is the tan ratio of the compound angle alpha plus beta, we're going to get tan alpha plus tan beta over 1 minus tan alpha tan beta. Okay, that we've seen before. And that's equal to 6 over 7. Now, tan of alpha and tan of beta, we can substitute out, and in their place, we can substitute in x over 1 plus x for tan of alpha. Okay, so that tan of alpha disappears, and we put x over 1 on x in its place. And then tan of beta, we can substitute that out, and in its place, we can substitute in x over 1 minus x. And likewise for the denominator, that's over 1 minus tan alpha tan beta. So instead of writing tan alpha tan beta, we could write that in terms of x. So that's x over 1 plus x times x over 1 minus x. And that's again all equal to 6 over 7. Okay, so I've written the solution to a kind of sideways just to save a bit of board space here. So if this was line by line, so this would be a line, this would be the next line. Now moving on. We need to eliminate the fractions inside the larger fraction or the embedded fractions. So what I've done, again, it's just algebra. If I just expressed things with a common denominator, these fractions with a common denominator, I can add the numerators together. So for this numerator here, this is x over 1 plus x over 1 minus x. If I multiply the x by 1 minus x, and multiply the second x here by 1 plus x, I can express it with a common denominator of 1 plus x, 1 minus x, which is 1 minus x squared, of course. All over this denominator here, so that's 1 minus x over 1 plus x times x over 1 minus x. And again, we can express that this denominator or the fraction inside this denominator with its own common denominator, which is 1 plus x, 1 minus x, and then you end up with 1 plus x times 1 minus x squared, all over 1 plus x, 1 minus x. So I know it's looking rather messy at the moment, and this is sort of the whole point, that we can eliminate something here. So you notice that within the larger fraction here, this smaller fraction, in fact, I'm just about run out of space here, but I might just see if I can just move that up a little bit. Yep. In fact, if you write this as a division, okay, if you were to write this as a division, okay, that's like saying A over B all over. Okay. I wonder if I can. Oh, no, that's not going to work. So actually, I might just write it here, just there. So A over b all over c over b, right? And that's the same as saying a over b divided by c over b. A quick way is we can just cancel out the b's. So I'm going to do the same thing in this fraction. You see, I was just trying to go through just some basic algebra there. That means that we can in fact cancel that out and that out there. So these are the two denominators of the two fractions that are in fact part of the numerator and the denominator of the larger fraction. So this is the complication with the fraction inside a fraction business. Now again, all of that's equal to 6 on 7. So once we cancel out these two denominators, it looks a little bit simpler now. So we end up with x minus x squared plus x squared over 1 minus 2x squared is equal to 6 over 7. And that's equal to 2x over 1 minus 2x squared, or equivalent of 2x over 1 minus 2x squared equals to 6 over 7. So just collecting the like terms, of course. Now if we do the whole cross multiplication, you end up, and I've skipped a few steps here because I've run out of space in fact. If you just do the cross multiplication, you end up with 6 minus 12x squared is equal to 14x. And if we just combine everything to one side, you actually end up with a quadratic. So you end up with 12x squared plus 14x minus 6 equals 0. And hopefully solving a quadratic is not an issue here. So I haven't shown that particular step, but of course you can use the quadratic formula or whatever method you like. And we end up with x equals negative 3 on 2, or x equals 1/3. Okay, and of course you can take those two values and you can test those values within the original equation. So get the value of the left-hand side, compare it with the value of the right-hand side, and I've tested it and it does work, but you can test that for yourself and you should see that left-hand side equals right-hand side in both of these two cases. Thank you for watching.